Beneath the Waves, an introduction to submarines. Submarines. These underwater vessels, marvels of engineering, navigate a world hidden from our everyday view. They move silently and efficiently, exploring the vast, uncharted territories of the deep sea. They represent a unique blend of human ingenuity and the relentless pursuit of exploration, both for peaceful purposes and, unfortunately, for conflict. The technology behind submarines has evolved significantly over the years, making them more sophisticated and capable. Submarines are broadly categorized into two types, military and civilian. Each type serves distinct purposes and is equipped with specialized technology to fulfill its mission. Military submarines are designed for naval warfare. They're built to be stealthy, powerful, and capable of operating in hostile environments. They carry a variety of weapons, including torpedoes and missiles. These weapons systems are designed to engage enemy vessels and targets with precision. These submarines are also equipped with advanced sonar and radar systems for detection and stealth. These systems allow them to detect other vessels and navigate the underwater terrain with accuracy. Civilian submarines, on the other hand, are primarily used for scientific research and exploration. They play a crucial role in expanding our understanding of marine biology, geology, and underwater ecosystems. They often feature specialized equipment for deep-sea observation, sample collection, and underwater archaeology. These tools enable scientists to study the ocean's depths in ways that were previously impossible. These vessels provide invaluable insights into the least understood parts of our planet. They help uncover the mysteries of the deep sea, from ancient shipwrecks to new marine species. Whether military or civilian, all submarines share the same basic principle: the ability to control their buoyancy to submerge, travel underwater, and resurface at will. This capability allows them to operate in a three-dimensional environment, unlike any other vehicle. This delicate dance between the ocean's pressure and a vessel's carefully calibrated systems is what makes submarines such fascinating feats of engineering. The balance of buoyancy, pressure, and propulsion is a testament to human innovation and the desire to explore the unknown. Daring dreams, early submersibles, and war at sea. The journey into the depths of the ocean has always been a daring dream for humankind. The concept of underwater navigation has captivated the human imagination for centuries. From ancient myths of sea monsters to the scientific curiosity of the Renaissance, the idea of exploring beneath the waves has been a constant source of fascination. Early inventors with rudimentary materials and a thirst for discovery crafted the first submersibles. These pioneers faced numerous challenges, from the lack of advanced materials to the sheer danger of underwater travel. One such pioneer was Cornelius Drebbel, who in the early 17th century built what is considered the first navigable submarine for King James I of England. Drebbel's creation was a marvel of its time, showcasing the potential of human ingenuity. The 19th century saw further advancements. Inventors and engineers continued to refine submarine designs, making them more practical and effective for underwater exploration and eventually military use. The American Civil War witnessed the use of the H.L. Hunley, a Confederate submarine that successfully sank a Union warship. This marked the first time a submarine had sunk an enemy vessel in combat, proving the strategic value of these underwater machines. This event marked a turning point, demonstrating the potential of submarines in warfare. The success of the H.L. Hunley inspired further innovations and investments in submarine technology. World War I saw the rise of the U-boat, Germany's stealthy underwater weapon. These submarines were equipped with advanced torpedoes and could remain submerged for extended periods, making them formidable adversaries. These submarines, with their ability to strike unseen, wreaked havoc on Allied shipping, changing the face of naval warfare forever. The U-boat campaigns of World War I highlighted the strategic importance of submarines, setting the stage for their continued development and use in future conflicts. Mastering the depths: how submarines function. Submarines are marvels of modern engineering, allowing humans to explore the mysterious depths of the ocean. The ability of a submarine to submerge and resurface at will depends on the principle of buoyancy. This principle is the same one that allows ships to float on the surface of the water. Submarines have ballast tanks that can be filled with either air or water. These tanks are crucial for controlling the submarine's buoyancy. To submerge, the tanks are filled with water, increasing the density of the submarine and causing it to sink. This process is carefully controlled to ensure a smooth descent. To resurface, compressed air is pumped into the ballast tanks, forcing the water out. This reduces the submarine's density, allowing it to rise back to the surface. This makes the submarine less dense than the water, causing it to rise. The transition from underwater to surface is a delicate operation requiring precision. Propulsion is achieved through a combination of diesel-electric engines for surface travel and electric motors for underwater movement. This dual system ensures efficiency and reliability. Nuclear-powered submarines, developed later, use a nuclear reactor to generate electricity, providing almost limitless underwater endurance. This advancement has revolutionized submarine capabilities. Life support systems are critical for the survival of the crew in a sealed environment. These systems ensure that the crew has everything they need to live and work underwater for extended periods. Oxygen is supplied, often through an electrolysis process using seawater. This process splits water molecules to produce breathable oxygen. Carbon dioxide is scrubbed from the air. This is essential to prevent the buildup of CO2, which can be harmful to the crew. Sophisticated systems manage waste and maintain a habitable atmosphere within the submarine. These systems are designed to ensure the health and safety of the crew, making long-term underwater missions possible. Silent Hunter's military submarines and their missions. Military submarines have evolved into highly specialized vessels, each designed for specific strategic roles. Attack submarines, smaller and more agile, are tasked with hunting down enemy submarines and surface ships. They are armed with torpedoes and guided missiles for close-quarters combat. Ballistic missile submarines, in contrast, are the ultimate deterrent force, lurking silently in the depths. These behemoths carry intercontinental ballistic missiles, or ICBMs, armed with nuclear warheads. Their mission to remain undetected and serve as a guaranteed retaliatory strike capability. Cruise missile submarines bridge the gap between attack and ballistic missile submarines. They are designed to launch cruise missiles, which can travel long distances and strike land targets with precision. These submarines offer a versatile platform for both strategic and tactical operations. Section 5. Windows to the Abyss. Submarines for science and exploration. Beyond the realm of military applications, submarines have become invaluable tools for scientific research and exploration of our oceans. Deep-diving submersibles equipped with powerful lights, cameras, and robotic arms allow us to observe and interact with the deep sea. Scientists use submarines to study marine life, geological formations, and hydrothermal vents. These vents, spewing superheated water rich in minerals, support unique ecosystems that thrive in the absence of sunlight. Submersibles also play a crucial role in underwater archaeology. They allow for the exploration and documentation of shipwrecks, offering glimpses into maritime history and lost civilizations. The discoveries made possible by research and exploration submarines expand our understanding of the planet and highlight the importance of ocean conservation. Section 6. Pushing boundaries, innovations in submarine technology. The field of submarine technology is constantly evolving, driven by the need for greater stealth, endurance, and operational capabilities. Stealth technology, a key area of advancement, focuses on reducing a submarine's acoustic, thermal, and electromagnetic signatures. Anechoic tiles, special coatings that absorb sonar waves, make submarines more difficult to detect. Improved propulsion systems such as quieter pump jet propulsors further minimize noise. Autonomous underwater vehicles, or AUVs, represent another significant leap forward. These unmanned submarines, pre-programmed or remotely controlled, can perform a variety of tasks, from oceanographic surveys to mine detection, without risking human lives. Section 7. The abyss gazes back, challenges of life beneath the waves. Operating in the unforgiving depths of the ocean presents numerous challenges. The immense pressure exerted by the water column at depth demands incredibly strong hulls. Even a small leak at depth can be catastrophic. Life inside a submarine, particularly during long deployments, can be psychologically demanding. The crew faces confinement, isolation from the outside world, and the constant awareness of the dangers lurking just meters away. Communication with the surface is limited by the properties of water, which absorbs radio waves. Submarines rely on specialized underwater communication systems, but these have limited range and bandwidth. Section 8. A glimpse into the future, submarines in a changing world. The future of submarines promises continued innovation and adaptation to new challenges. Advanced propulsion systems, such as fuel cells and magnetohydrodynamics, offer the potential for even greater stealth and range. Artificial intelligence and automation will play an increasingly important role in submarine operations, reducing crew workload and enhancing decision-making in critical situations. As we delve deeper into the oceans, environmental concerns come to the forefront. Future submarine designs will need to minimize their impact on marine ecosystems. This includes reducing noise pollution, which can disrupt marine life, and developing environmentally friendly waste management systems. The submarines of tomorrow will continue to push the boundaries of human ingenuity, offering us new ways to explore, understand, and protect our oceans.